Hey everyone, this is Avinash back with another video. In this video, thank you. Just experiment with different video. In this video, let's discuss about more parameters. Especially, we'll be discussing about what are samplers, what are sampler steps, and what are sampling methods. Okay, so samplers. So to create an image using stable diffusion, the first step is to generate a random image from the database. Okay, so then noise predictor estimates the noise in the image. This estimated noise is then removed from the image. This whole process is repeated multiple times to gradually get a clean image, right? So this is how it works. You have a basic image in the first, like with a lot of noises, and then noise predictor predicts some kind of a noise to be removed. It gets removed in the first step, and then happens again. Noise predictor predicts more noise, and then it decreases, and it happens over 25 steps to 100 steps, or 20 steps to 100 steps approximately. So this is how this process works, and this is how usually the diffusion models work. So denoising process is known as sampling because the stable diffusion generates a new sample image at each step. This technique is used for this process. The technique used for this process is called sampler, right? So the technique is sampler, and the whole process is sampling, right? So you got it, right? You got samplers and you got samplings. Now if you want to know sample steps, you go to your stable diffusions, the first line or something like that. Not first line. In your first screen of stable diffusion, you will find sampling steps. In the previous video, we discussed about steps, number of steps needed. So steps are nothing but sampling steps. That's it. So I use the term steps, but I just wanted to say you both the same so that you will be on the same page. So that is sampler steps. The more sampler steps you give, the more refinement or the denoising happens. Thereby you get more clarity images. That's all. So that's samplers, sampling steps, and everything. So we'll discuss about the 4 sampler methods that we have, that we use in the stable diffusion process, in stable diffusion. But before actually discussing about different sampler methods, let's first discuss what is a sampling method. So stability AI, otherwise stable diffusion, uses various sampling types when generating images. In general, samples allow for the development of finer details using a variational autoencoder, which is VAE, a type of artificial neural network that is used for unsupervised learning of a complex distributions. So that is one artificial, neural network which is used for complex distribution, and it is a generative model that is trying to learn a compact and low dimensional representation called latent space of data, and to generate new data samples that are similar to the testing data, right? So essentially it is like you give the data a lot of images, and using these samples it learns and then gives you more images from the learnings using a generative thing. Generative is not copy pasting, just taking inspiration from the database and creating its own image, because you have lots and lots of dots in that denoising stuff. So it can't reproduce the same features in the new image you generate from the inspiration image it takes. So it's pretty impossible, right? Because the lot of denoising has been taken. So VAEs are not just used for image generation; they also get used for natural language processing and representation learning, etc. So these are the handy for the tasks that involve large and complex datasets, because they can learn to extract useful features and patterns from the data in an unsupervised manner. You don't need to supervise them. So stability AI chooses to produce images based on sampling types. So differences between samplers can be very subtle. So these parameters are highly configurable so that you can experiment with them. Yeah, a lot will be dependent on your prompt. So feel free to try new things. So basically, you understood basic, what is a samples, right? So samples, you got it in the first, paragraph. Now, stability uses different sample types that are sampling methods. So just to cut this whole high level definition and to explain you what are sampling methods. So the way it reduces the noise and generate image from the prompt you give, it has 100 different methods usually. Out of 100 different ways one can generate image using the generating technique, Stable Diffusion has like 17 or 18 inbuilt already with automatic double one and double one thing, right? So once you install automatic, you'll have 20 sampling methods already, right? So different methods will have different way of getting you images. So sampler methods are nothing but different. So these are different models that use your prompt to generate your desired result, which is image in this case, in a different way, right? So they use techniques that were invented hundreds of years ago, some 10 years ago, some were invented by themselves, just like that. So now what happens is in Midjourney, you don't have the option, or you don't have that customization option of choosing your own sampling method for the needs you have. Midjourney just uses it's just inbuilt, just like iPhone, right? You don't have so many options. But whereas in Stable Diffusion, since it's an open source model, open source code or tool, it gives you the opportunity to use different sampling methods according to your needs. It's like the professional version or upgraded version of Midjourney. It works almost like same, but it has more and more options. Like if you want to be like a super high level AI digital artist, Stable Diffusion is something you need to explore. So now, as we discussed, we'll be discussing 4 sampling methods that work good for us. Right. So the first one is K_LMS, the trustworthy workhorse. This one generally gives you nice results with well-crafted prompts running quickly at 50 steps. If output doesn't look good, try increasing steps to 80, but check if the higher count really improves the results. Experiment with different step counts using while keeping other parameters the same. You might find the fewer steps work just as well, right? So basically, will not technically explain how each sampler method works, because that will just ruin your entire learning of Stable Diffusion till now. It's so complex that people rarely understand. It's better just to avoid how the sampler method works and just get the bird's eye view definition, but not the technical definition. So that's why we gave you the sampler methods example, but not showing how each sampler method works. So basically, K-LMS is a very good sampler method that you can try. So these are the 4 sampler methods we are giving you, right? So just try all the sampler methods which we are giving and stick to and use this for a different use cases. So stick to one, method for one use case and, explore them. That's all I can say. But sampler, K-LMS is a this trusty workhorse. So DDIM is a speedster, right? So DDIM can give fantastic results within just 8 steps and is ideal for creating lots of images very quickly and to test your prompt. So while testing new prompts, use DDIM with 8 steps to generate multiple images and see how your prompt performs. For the more complex prompts needing more steps, but check if actually increasing steps is a beneficial thing. Now maybe try that XY thing that we're going to show in the next videos. There is this XY parameter which we'll discuss. So that is also a good thing. Okay. So what I usually do is maybe start with DDID and then go back to KLMS once I'm very well aware that my prompt is good. It's as simple as that. And so K-Euler A, that is like the shape shifter. Much like DDIM, the sampler method is fast and works well with low step counts, 18 to 16, but it significantly changed the style of generation. The output at 15 steps might look very different from output at 16. So it's unpredictable, but can give you unique results. So feel free to experiment and compare its results with other sampler methods. So as you know, if you don't actually know what you want, like you have a rough idea of what image you want, but you actually don't know exactly what you need. So maybe you can use this sampler method because it gives you a lot of chaos, right? Chaos. The reason is something at step 8 will look a little different than 9. Whereas in the other, models, it's almost similar, but just getting finer and detailed. But here in this K-Euler A, it's little different, right? So let's also talk about KDPM -2-A. It's the perfectionist. So this sampler method might be the best for generating high quality images, but it's much slower than the others. In this step range of 30 to 80, it's highly effective. It's not ideal for the experimentation due to its slow speed, but for beloved prompt, it's worth the wait, right? Stick to K-Euler A or DDIM at lower step count while refining your prompts, and then maybe come back to this particular sampler method when you know you have the best prompt possible. And I also use Euler, just K-Euler without A. There is another sampler method. Even that is good. So these are the 5 sampler methods. These are like 4 most important, but then 5 are like the best, right? So if you see, this is how the sampler thing work. It is slowly reducing noise and GIF. So the process of reducing this noise using different strategies or techniques gives you different methods. One is like not all will use the same method, and then Midjourney sticks to one sampling method if I'm not wrong, or it just don't give you option to explore different sampler methods, but Stable Diffusion does. So it is your it's good for you to kind of go and experiment different things. So that's it for this video, folks. See you in the next video. Thank you. Just experiment with different things after seeing our walkthrough video. Bye bye.